Today we look at the basics of databases. This is not intended to be a substitute for a database class, but we need some basic knowledge of what the structure of a database looks like and how we can use SQL to get data from a database. This is, after all, a data analytics class. So let's take a look at the basics of databases. And the first thing to understand is that in a computer program, the data that we use in the program is transient. When the program gets turned off, or the computer gets switched off, or the program ends or crashes or whatever, all the data that the program is using is lost because it's transient. It exists only for that instant of time that the program is running or the computer is running, and then it's gone. But typically, when we have large chunks of data that we need to use for analysis, we need to store that data in a persistent fashion. That means that the data should be available forever, so to speak. So the key in understanding is that what we don't want is, what we want to be able to do is to get data from sources that are persistent. And typically, a persistent database is one that sits on a computer or a server or something and has an organized collection of data. So the key here is organized and data. It's data that's organized in some fashion, and there are many different kinds of databases. But the key is that they're organized and they sit permanently on the computer, and they are persistent, so you can turn the computer off, turn it back on, and it's still over there. That's the idea there, right? Or if it's on a server, you turn the server off and on, and it's still over there. And there are many databases like this, and typically the two types of databases that we usually end up using in data analytics are either a relational database or something called a NoSQL database. So let's take a look at what these things are. We will in a minute, but these are the two basic forms of databases that we want to consider. Who uses databases? Well, almost everyone does. If you take any application, you're going to be using a database. If you go onto the web, you go to Amazon.com and you type in your favorite thing that you're searching for, perhaps the latest drone or whatever, then what Amazon does is it goes to its database, sends a query saying find drones under $500 or whatever your query is, and returns a long list of drones, the things that satisfy that condition, and shows them to you. So Amazon has a permanent repository of data that contains all the products that are available for sale, and you're essentially, when you send a request over the web, you're querying that database. That's what you're doing. So almost everyone uses databases, and when we are interacting on the web, we are actually using a database whether we realize it or not. Well, most of the time anyway. The two kinds of databases that are of interest are relational databases and NoSQL databases. And relational databases are very straightforward kind of things. The analogy with tables is very clear. In a relational database, data is stored in tables, two-dimensional tables. So they look exactly like this, with column 1, column 2, etc., and row 1, row 2, etc. That's what a table looks like, and that's what we see inside a relational database. The idea in a relational database is that if you have a database, then the tables are logically connected. That means that you don't have tables that are dissociated from everything else in the database. Typically, they're connected through a column. So we might have a column here, like C1, for example, that is a key column, and that column is used in some other column as well. And then we can say row 1 contains data for whatever table this is, and we can find some other table that has the same value of C1 and then connect the two up. So the idea is that if you think of a relational database, you really have T1, T2, T3, and these are all linked somehow. Okay, may not be all of them linked to each other. For example, perhaps T2 and T3 are not linked, but you don't really want something that is like a T4 over here that is not connected to anything at all. Within the table itself, the columns are attribute values. So it's like an Excel table. You can think of having multiple Excel tables in a relational database. And the columns are social security number, name, phone number, stuff like that. So what we end up having is rows and columns. And we finally want to get data from this. So we use a language called SQL for information retrieval. And that's really the key thing that we want to learn out of all this. How do we write SQL queries to get data from a relational database? And the goal in a relational database is to do two things: to make sure that the database has very low redundancy and is maximally consistent. Redundancy means that if in a database you have the same data repeated twice or 3 times or 10 times or 15 times, then that's redundant. So if you have, for example, let's say your name is John Smith, and you in table 1 there's John Smith, a row that corresponds to John Smith, and say your address, right? So let's say you live in New York. And then table 2 also has the same thing: John Smith, NY, and maybe some other information attached to that. This is redundancy. We have the same piece of information, NY, NY, and John Smith repeated in the database. That's less than ideal, because what will happen if you move from New York to Paris, right? If you move to Paris, we have to find every instance of your address in our database and change it, and that's not so good. You forget it in one place, then what you're going to have is, like if you go here and we say, hey, we've changed NY to, say, France. Okay, and now if I ask the database where does John Smith live, if the database goes to T1 and gets the address from there, it's going to say France. And if it goes to T2 and gets the address from there, it's going to say New York. And what that means is that we have a database that is no longer consistent. Consistency means that the database should give you the same answer to the same query, irrespective of how that query is executed. In the case of our example here, if the query was executed by looking at T1, we get one answer. If the query is executed by looking at T2, we get a different answer. So that's inconsistent. So redundancy leads to inconsistencies, and of course to wasted space and all kinds of other things as well, not so nice things as well. And the goal in a relational database is to make sure that we have minimal redundancy and maximal consistency in the database. The second kind of database is called a NoSQL database, and this is really not a single type. A NoSQL database is essentially a database that doesn't use SQL for SQL, that is SQL, SQL are interchangeable terms, for accessing data. In other words, it's not a relational database. So NoSQL databases are typically used for very large data sets and often on the internet. And the idea there is that you have a very large data set, and let's say you have a row of information about a person that contains every possible piece of information known about that person. You know, what their web habits are, what they spend money on, all their credit card numbers, their addresses, their spouse or previous spouses, their children, their children's ages, their children's schools, you know, all kinds of stuff. So you have all this data. In a relational database, typically that data will be spread out over multiple tables. And if you want to access all that information in one step, then you have to go to multiple tables and collect that information and then produce the result. And that can be slow. If, however, you know that your application is going to actually get all that information in one step, it's going to require that information the complete information in one step, then maybe it makes sense to, rather than storing it in a NoSQL database, to store it in a rather than storing it in a relational database in multiple tables, to store it in a single record of some form or the other, right? A single data element. And then you say, get me the data for John Smith, and the entire data, his history, the kids' history, their spouses, ex-spouses, parents, grandparents, grandchildren, whatever, can show up in one shot. So that's the idea with this, with a NoSQL database. Often that record is stored in a JSON format. We've already seen JSON formats. So often that the format is either JSON or something similar to that. But the idea is that whatever makes the most amount of sense in terms of getting the data as fast as possible. In other words, you want low latency. So you have to know beforehand how you're going to query the database. If you don't know that, if you want generalized querying, relational databases are better. But if you have a specific form of querying, then you need to think about, okay, I know this is what I'm going to get, so I might have a store in a format that brings it out very, very quickly. The second nice thing about it is that it's very scalable. because if you want to add more records to the database, you can think of it as having one giant table with all the information. So some new person comes along and you want to add all the information about them, you just tag it on at the bottom. And you can keep tagging on at the bottom. And in fact, if you run out of space, you put it on the cloud, you just get another machine, another machine, another machine, another disk, whatever, and you can go on forever. So it's very scalable. And the downside, of course, is that there's lots of redundancy. So the same information may be stored in multiple places. For example, if we have John Smith's entire history in one record, and we have that includes his children's history, and if you have, let's say his kid is Jane Smith, so Jane Smith's record is in a different record, information in a different record, and we have all that information there, it's duplicated. We already have it with John Smith, but we need to duplicate it with Jane Smith, because if our query says get me information on Jane Smith, we don't want to have to go and first find John Smith and then get her data. That's the idea. So there's a lot of redundancy built in inside a NoSQL database, which is an issue because we're talking about very large data sets, but it's also less of an issue because computing power, the price of storage, all these things are actually getting lower as time goes by. So since they're getting lower, redundancy, at least in storage terms, is not a big deal. We still have the issue of inconsistencies, but we have to live with that. Okay. So like I said, typically they're stored on a cloud because that's where you want to have the scalability. And it doesn't use SQL. That's why they're called NoSQL. There may be some NoSQL databases that use SQL. I don't know if any, but the idea of NoSQL really says it doesn't use SQL. And there's some very nice examples out there. There's MongoDB, which is a proprietary commercial database. There's Google Bigtable, that's brought by Google, and you have to pay for using it above a certain amount. There's Sparksy, there's Amazon DynamoDB. So these are the possible vendors or users of data or possible database servers you can get that are NoSQL databases. We are not going to look at NoSQL databases in our class. And the easiest of these would be, if you really want to look it up, is to look up MongoDB. MongoDB is a very simple database. It also uses a JSON format. We're already familiar with that. So it's something really familiar for us. So that should be really easy to use. Or you could use Google Bigtable or Amazon DynamoDB, but just note that if you beyond a certain threshold, a fairly small threshold, you're going to end up paying for it. So which is not a very great thing. But MongoDB, you can get a free license for certain uses, so it's not a bad thing to start with. So that's up to you if you want to do that. We're not going to do it in this class. We don't have the time for that. What we're going to do is we're going to focus on relational databases.